Chapter 2. Chapter 2 really fully begins the study of functions. We're going to take them one at a time. The first function that we look at is the linear function. That's one we've been working with for a very long time. That's y equals mx plus b. And then in this chapter, the second one we look at is the quadratic function, which is y equals ax squared plus bx plus c. So we're going to look at them. We're going to redefine them. We're going to look at the domain, the range, x-intercepts, y-intercepts, graph, anything else that is particular about that function. Okay. Plus, we're going to be doing some what we call mathematical modeling. That's word problems in a different direction, which is where this stuff actually becomes useful. Linear function, f of x is equal to mx plus b, where m is the slope of the line, b is the y-intercept, which is x equals 0, y equal b. You have the domain being all real numbers because there's no denominator, no radical. We're going to be looking at something called the average rate of change. I normally, and especially once we hit calculus, I call it AROC for average rate of change. It is the change in y divided by the change in x. Delta y over delta x would be another nomenclature for it. We know it's the slope of the line. So average rate of change is just the slope of the line. So in other words, we're putting another name to something that we know. Now, why would we do that instead of saying slope? Because average rate of change is more related to word problems. When I'm looking at applications, I'm not looking for slopes as much as I'm looking for how x and y are related, and that's the average rate of change. So that says as x changes so many units, y changes so many units, that's average rate of change. So we need this for our applications, but it's the old furry friend, slope of the line. We're going to look at this in several forms. If I look at wanting to graph something of the effect h of x is equal to negative 2/3 x plus 4, I notice that the slope is just the coefficient of x, so it's going to be negative 2/3, and the y-intercept is when x equals 0, and that eliminates the x term. That's this guy right here, and he's 4. If I look at the domain of this guy, he's no radical, no denominator, so his domain is all real numbers. And so range we usually get off of a graph, but we know kind of what a line looks like. A line that has slope, by the way, he either goes up or he goes down forever and ever. That's his image. And so his range would be also all real numbers. And we can verify that with our graph. There are several ways to graph him. And the way I would use if I were working this particular problem is I have the y-intercept, I have the slope. Now what does the slope tell me? This slope tells me essentially how y is changing with respect to x. I can write this as a negative 2 divided by a positive 3, which says if x advances 3 units, y descends 2 units. And that gives me another point on that line. That's what slope does. So that says if I know a point, which is 4, if I advance 3 units in the x and decline 2 units in the y, I would get a second point on that line. Bless you.
Thank you.
And then I would take my straight edge, if I could find it. Any straight edge would do. I actually at one point had a ruler. So I'm just going to grab a piece of paper. have a little stack here, and then line it up. And draw. Oh, you could do it freehand, even with a straight edge. I don't get a perfect looking line. And that's kind of what he looks like. Need my ruler. Or a better straight edge, one of the two. Now, AROC is the average rate of change. We know that what the average rate of change is just the slope. So the average rate of change is negative 2/3. This is the slope of the line. Now, is this increasing, decreasing, or constant? That says as we move from left to right, is y going up or y going down? Down. So as a result, he is decreasing. And you're always moving from smallest x to largest x for increasing and decreasing. And by the way, we know he's decreasing anyway because the slope is negative. That means decreasing. So some new nomenclature, new vocabulary. Now here we go again. It says find the zero of each function. Zero. Zero for us, we're going to pick up additional words. Zeros are really x-intercepts because y equals 0. That's where the word zero comes from. Sometimes, and even our calculators might use the word root. Root is the same thing. You'll find that in the next chapter. Find out roots. Roots are the same thing. So a zero, a root, and an x-intercept mean the same. That means y equals 0. So if I look at the zero means that y equals 0, or 1/3 x minus 4 equals 0, or 1/3 x equals 4. Now, instead of dividing both sides by 1/3, I need a 1x. So I'm going to multiply both sides by 3. That clears the 1/3 so that x is 12. So what's the 0? The 0 will be x equals 12, y equals 0. Pardon me?
2 minus 2 said.
And of course the y-intercept is sitting right there. So the y-intercept is x equals 0, y equals negative 4. Now I'm going to do the same thing with the graph, because even though I've got two coordinate points, if I wanted to use 0, negative 4, and 12, 0, because that's the only need 2 points to do, my graph paper only goes to 5. So that means I'd have to scale it. But in the form 1/3 x minus 4, I could just use the slope-intercept method of graphing. So I know that b is negative 4, and I know that m is 1/3. That means I go over 3 in the x and up 1 in the y. Now, am I going to expect now that my graph is going to be increasing or decreasing? Increasing, right? It's going to be going up. So negative 4. Then I'm going to go over 1, 2, 3, up 1. That gives me another point. And then I look for another straight edge. Let's try this one. And there he is. That's about as exciting as it gets.